Hello, I would like you to imagine this. You are working for a fashion brand as a buyer, and it is your job to go out to manufacturers and to order thousands and thousands of clothes. And you ask yourself a simple question: how many white shirts, such as this one, do I need? And then this little guy comes and he says 12. Cool little guy, but there's also brown and gray and black and other kinds of shirts too. And one slight complication though is that you have to do this ordering 7 months in advance because that's how the fashion business operates. And all of a sudden, the answer goes from 12 to because this is not easy to do. There are many variables that affect the number of white shirts that a brand can sell 7 months from now. To make answering this question almost impossible, you work for a fashion enterprise that has 20 brands under its roof, and each one of these brands has tens of thousands of clothing items that are being sold through online, retail, wholesale, partner channels, and similar. And I think you see where this is going. Predicting this demand accurately is very difficult, and you absolutely have to go data-driven. Any other way is going to be wrong. In fact, data-driven way may also be wrong, but it's going to be the smallest amount of wrong. Because when it comes to selling clothes for a living, you absolutely have to have the right product at the right time for the right customer and for the right price. The consequences of being wrong are going to be felt worldwide, because if you have to produce more clothes, then there is going to be more chemical agents used, more water used, and more CO2 released. And knowing how much this fashion enterprise is committed to their sustainability goals, this is absolutely the last thing they want. In the end, of course, there will be a commercial impact if you have too many or too few clothes. This fashion enterprise is built up of 20 individual companies, each with their own individual budgets, their profit and loss margins, their employees, and their decision-making processes. And this is great for the business because it provides them with autonomy and speed to be competitive. On the other hand, it can show its ugly side when technical decisions are not governed from a single place of authority. Then you can end up with all kinds of data storage systems, such as small databases, big databases, in the cloud, on-premise, on your laptop, in Excel files. You name it, it will exist. And then answering the question from the beginning becomes impossible, because the data that you need to come up with an answer is either siloed or unavailable. It may be governed differently or not governed at all. And we have realized this, and we also came to a conclusion that a unified data and analytics platform is what we need. Something that will help us turn data from a byproduct of the business to an integral part of the business. We have decided to build this platform with Terraform, with everything as code approach, and with the DevOps principles applied to it. And we have implemented and built this platform at Bestseller, which is one of the largest fashion enterprises that is behind the brands that you see on the screen. My name is Ivica, and I work as the lead data platform engineer. And my team helps data engineers answer important questions that these brands may have. And the solutions that my team delivers are quite techy, and their value to the business is not direct. What we provide are the very basics: tools, the processes, the infrastructure that others will use. And those tools and processes will be used by data engineering teams to crunch data, to transform data, and to ultimately build data products. Then come data analysts that will use these data products to draw conclusions. And in the end, the management team can make decisions based on those conclusions with a degree of calculated risk that they are comfortable with making. The data platform, in its essence, enables data producers to ingest raw data that is transformed and built into data products to be served to data consumers. We decided to take the managed approach. To make it a platform, we are standardizing everything that can be standardized across teams, like tooling, like processes, like security guidelines. We also take it on ourselves to do the heavy lifting that doesn't really provide value, so that our stakeholders can focus on what they do best, which is providing direct value to the business. The standards that I mentioned are very important because the number of producers and consumers will only grow over time, and they will be different in a way that they function. So by standardizing on how they can connect to the platform, how their access is managed, or how security guidelines are applied, we actually allow for this growth to happen. These data producers and consumers can be separated into data domains, and you can say that a domain is a logical grouping of data that belongs to the same category. One example of a data domain would be the retail or the finance domains. And I think this was enough theory, so let's look at some practical examples of what we built and how we did it. We of course use Terraform to manage all of the infrastructure on Snowflake and on Azure. We use Vault for secrets management, of course. Other tools such as Airflow, dbt, and Databricks are a part of our platform, but they are mostly used by our stakeholders. My team also uses Ansible a little bit, and I will show you a very nice example of how Ansible fits into the whole picture. If you were to ask a different persona within this enterprise to define a data domain, they would probably tell you a different thing. Security folks may say that a domain is a security boundary. Data engineers will just see it as a grouping of data belonging to the same category. And me being a platform person, I see it as a few Azure AD groups, some Snowflake roles, and that's it. All of these views are correct. But the biggest realization that we had was that this is just infrastructure and we can just manage it with Terraform. What you see here is an example of a Terraform module that creates the finance domain. Our end users can use this module whenever a new domain naturally forms as a grouping of data, and they provide just two inputs. The first one is the name of the domain, and the second one is the list of owners. In a nutshell, the domain module creates a few Terraform resources, a few Snowflake roles, some Azure AD groups, and then configures SSO between them. What it enables for the platform is much more important, because by specifying the owners and configuring these Azure AD groups, it sets up a very clear ownership structure so anyone outside of the domain knows who is responsible for data access permissions. The Snowflake roles, on the other hand, provide a very clear governance object. We have defined functional roles, they have least privilege permissions applied in every domain. And finally, by having all of this in a module, allows the platform to be used in a self-service way by the users. As a matter of fact, my team does not use this module at all, because we don't know what constitutes a data domain. Our users do. Domain on its own, of course, doesn't really do much, so we need the almighty database for it. And we see these Snowflake databases as the building blocks and cornerstones of each domain. The databases are split into raw, where the raw data is, and analytics, which holds analytical data. And they, as I said, represent the core of a data domain. So how do you create a database? By using our Terraform module. It tries to have a very simple interface, and only two inputs are required: the type of the database and the domain to which it belongs. When it comes to Terraform resources that this module creates, the number is between 45 and 50, which is a lot, of course, but that's only because it covers a wide range of functionality that Snowflake provides. The module also takes care of setting up the permission roles and tags all the objects that it creates. But what it enables for the platform is again far more important than the resources it creates, because this module enables sustainable growth by offering a self-service interface of managing infrastructure to the platform users, to the domains. It uses this cookie-cutter template approach to roles, and this module is a perfect place where governance is managed from. With those tags on objects, the module is also the perfect basis for cost reporting and for optimization, and it allows us and every domain user to understand how much it costs to load the data or transform it or put it as a data product. In the end, a database is a building block of a data mesh. And as Beverly would say, if one is good, then two must be better. So let's look at a second database. What we have here is an analytics database for the finance domain, and it will hold some financial information, data products that have financial information. This data is loaded by the finance loader role, and you might think, who could be interested in reading this data? It could be the data analysts from the sales domain or the people from the retail domain. And with this simple change, these roles are allowed to read the data from the database. And by making this change, by doing this, you are connecting different domains like finance and retail, and you are creating a data mesh, which is the architecture that assumes multiple self-sufficient domain teams that will source and transform and create their own data products. In reality, of course, the data mesh may look a bit more like this, because not every domain is going to be connected to all the other domains. You may have domains that have a more interesting data, or others that have data that is a bit less interesting. No one may be connecting to it, but it's still an important part of the mesh. The cool thing about this is that the mesh is created and managed with Terraform completely. It sets up the owners that have full ownership of their data. It also gives them control to review code that grants access to their databases. And why is that? Well, that is because whenever a code change is made on a Terraform file, the owners are contacted and they will approve or not approve the pull request which grants access to their data. When it comes to the code organization, we have been running all of this in a monorepo with the following structure. We first split into environments, then we split into tools and services such as Snowflake or Databricks or Azure, and in the end, we have a Terraform file per domain. And with this structure, what it allows us to do is use the code owners feature of GitHub to actually notify the relevant domain owners whenever their code is changed. And it also allows us to split the state effectively, which I will show in a few minutes. On the other hand, there are a few downsides, of course. The repository has grown quite a bit because we have more than 40 domains at the moment. And sometimes we see more than 10 pull requests at the same time at the start of the sprint, right? So when it comes to applying these code changes, each environment, dev, test, or prod is, of course, its own state. And with this, we can achieve a full Terraform apply on the largest environment in less than 5 minutes, which is very acceptable for us. The dev environment will allow applies to happen from a feature branch. And with this, our stakeholders have a very low-risk way of making sure that their changes will work and that they will actually create what they expect before they proceed to making them on the higher environments. When it comes to applying changes to these higher environments, it's only possible from the main branch after a thorough code review, of course. We do realize that there are certain drawbacks to this approach, especially on the dev environment, where stakeholders will overwrite each other's changes, and they are, of course, aware of this. But we have decided that this is a small price to pay for us so that we can have reduced risk and get all the benefits in return. Because, as I said, the repository has grown, we have seen a few state locks happening, especially on the start of the sprint when everyone just wants to get their data, get their databases set up and everything. Talking about setting up databases, now that our data mesh is meshing and everything works the way we want it to, we also wanted to keep it that way. And for that, a good observability is needed. As a company, we use Data Tool and also we use it to monitor our platform, and it works fairly well. Sometimes you need just a little bit help from Ansible. And I know what you might be thinking, because Ansible is not a monitoring tool, but it does play a key role in our platform. Let me show you how. Datadog is more than capable of monitoring Snowflake with its integration, but these are system-level metrics, such as failed logins, query runtimes, and similar. Our stakeholders have a need to monitor the operational side of their workloads, such as whether the file ingestion was successful from the storage engine. And they, of course, want to be alerted when this fails. This scenario requires that we run a Datadog agent in a virtual machine and configure it with some custom checks. And Snowflake, thank you, has operational data in these special tables and schemas. So you can absolutely make a query that is going to be querying that data and comparing the results with the values that you expect. Perfect. But how can a data engineer get this query to the VM? And if you say SSH, not a good way to go. Please don't say it, SSH. It will complicate everyone's lives unnecessarily because we have 70 stakeholders and we are serving them, and it is unrealistic to expect that all of them will know how to use SSH or actually want to use SSH. How do you manage network access to the VM? How do you manage authentication with keys, everything? SSH is simply not for them. When I think of it, my stakeholder does not need to know about any of this. What they do is they write SQL for a living. So enabling them to create custom metrics on Datadog by writing SQL is a dream come true. So what actually happens is they will commit their custom check, their custom query to a repository. Our CI will take over, and it will Ansible will pick it up and will perform the necessary dry runs, making sure that all the SQL files are correct, and it will then configure the Datadog agent. What's amazing is that it will run the checks to see whether they actually work and do a rollback if that's not the case. And with this change, with this approach, our stakeholders have a completely self-service way of monitoring their operations. It does create a bit more work on my team, such as needing to run and maintain this virtual machine, but we see the benefits, and they far outweigh the cons. We have been running and building this platform for almost 2 years now, and we have had our fair share of challenges, of course. The first one being, I don't know Terraform, that every stakeholder ever. And that is a fair point, because they don't necessarily need to know Terraform. They do data engineering, machine learning, they optimize database queries, and it's a full-time job already. So what my team decided is to build everything with asymmetric complexity. It should be easy for the user to adopt and use the platform, and the complexity should be on us. We apply this to the platform, to our Terraform modules, to our documentation, and to everything that we support and maintain. So to minimize the cognitive load of using the platform, we have introduced some simple guidelines when building modules. Our modules have to have a simple interface. Use sane defaults, use data sources, locals, null resources, any trick up our sleeve to deal with the complexity. And also try to keep this similar interface between modules. Every module, of course, must contain documentation with multiple examples of how to use it. We also do regular trainings for new stakeholders, and we never miss a chance to do some internal marketing by sharing success stories. When it comes to modules, they also must be versioned. That way we compartmentalize, we keep breaking changes behind feature flags, but what we also do is radiate knowledge and experience by keeping things from going wrong. And this, in turn, creates trust in the platform. To give you an example of the simple interface that I just mentioned, let's look at the data module again. Stakeholders literally need to change 2 lines. That's it. Copy-pastable. Set and forget. The same goes for the Snowflake database module. Just 2 inputs are required to create a database. Yes, the database module can have a more complex interface when you start dealing with permissions and being a part of the mesh, but they are still very simple lines that need changing. On the other hand, to make these permissions on Snowflake a reality, there's probably 20 resources, 5 data sources that need to be maintained, but this is on us, this is on the platform team. To use the database module again, I want to show you how we keep the module interface consistent between modules. On the left side, we see that read access is given over certain schemas, not to the whole database. But the changes that the stakeholders need to make are minimal, and they are almost identical to the changes on the right side, where access is given to the whole database. It goes even further than this. What you see on the left is the database module, and on the right is the storage account module for Azure. And the interface that they have is almost the same when it comes to these generic inputs. Even the permissions or access management is kept behind this same or similar interface, even though the module implementation is completely different. On Azure, it's not even about accesses to databases. It is about roles that are given to identities, which is very different from Snowflake, right? But for our users, it looks the same. They specify a name of the principal that needs read access. Another challenge that we encountered is understanding when Terraform is not the right tool for the job. So if you look at a typical database in Snowflake, it will have several schemas and dozens of tables in each of the schema. As I've already shown, we are creating these databases with a module. Works perfectly well, but when it comes to managing schemas and tables, Terraform is not the way to go because these are fast-moving objects. Terraform is too rigid to manage them, especially on the scale that we are using it. So what should you be using to manage these database objects? What is the right tool for the job? Well, I had no idea, but I know who knows. My stakeholders, because they deal with databases and their objects all the time. And when asked, they suggested either Liquibase or Flyway or similar tool to manage and to version control these database objects. That wasn't the challenge, really. The how is mostly easy. The what is mostly easy. The why is what you need to work on, and I'm happy to report that we are getting there. Saying why is it important to manage database objects with code was a subject of a couple of discussion sessions back and forth between teams, between us and our stakeholders, but it's finally there, and I'm proud to say that it works. It really, really works. Something that we haven't solved and something that is, of course, out of our control are the providers that we are using. And it is absolutely great that the Snowflake provider for Terraform exists and that its development is very active. We can have more resources, improved security, and it does show a commitment from Snowflake to the Terraform ecosystem. But it also means that there may be breaking changes where you don't really expect them, like resources being removed on a minor version bump. Similar thing when it comes to the Databricks provider. It is absolutely great that it exists. It allows us to manage multiple workspaces and objects with them, but it doesn't really inspire much confidence if you open a resource documentation page and it has 10 notes or warning fields about the resource. Similar situation with the dbt cloud provider. It's great that it exists. It allows us to manage multiple dbt cloud projects. But if the version number of the provider looks like a bomb timer in a cheesy action movie, I will really think twice before using it. And don't get me wrong, all three of these challenges are not a deal breaker as long as you can work within those constraints. And we have been able to without any major issues so far. Still, despite all of those challenges, we have achieved some very good results. When it comes to growth of the platform in the past 20 months, we have seen a 6-fold increase in the number of domains and a stunning 900% increase in the number of databases with at least as many data products. On the technical side, our 60+ contributors have made more than 1,200 pull requests with more than 1,000 lines changed. And what this shows is that our stakeholders have accepted Terraform as the de facto tool for making the data and analytics platform a reality. Their confidence is high, judging by the changes they are making daily, and also we always hear a positive buzz whenever we talk to our stakeholders. What we have built definitely feels like a platform, and whenever I think of a platform that provides value, I think of an oil rig such as this one, and those brave men that work on them, that eat and sleep and live on them, absolutely have to trust the platform. The greatest compliment that anyone could give the platform is the trust that we see that our users have. It hasn't been easy though, especially knowing that we are outnumbered because there are only 3 platform engineers and we serve between 60 and 70 data engineers, scientists, and machine learning engineers. They in turn have more than 100 direct stakeholders that will analyze data and make conclusions, and all of those conclusions will serve a business that has 7 billion euros in turnover each year. Because we saw that this is working, that data domains and Snowflake resources can successfully be managed with Terraform, we just applied the same approach for Vault resources where the secrets are, to our Airflow, which orchestrates the flows between these tools. We use the same approach to our Azure resources and their modules, and to Databricks workspaces as well. which makes the platform a one-stop shop for actionable data that is as available as electricity. To get to the takeaways, I have a little story for you. Where I'm based, I am very close to the Amsterdam's airport called Schiphol. And I'm so close to the airport that I can easily tell which plane belongs to which company when they are flying over my house. And I was interested one day, so I was reading a little bit about the airport itself. And apparently it has 6 runways that you can see here, shown in purple and gray. So here's a question for you. Are the runways shown in purple used for landing, and those runways shown in green used for takeoff? Or is it the other way around? The purple runways are actually for taking off, and the gray runways are for landing. I know that you cannot tell me, but just have a thought about it. While you're thinking, let me give you some facts. Schiphol is a very busy airport, and on average they have 1 takeoff or landing every minute, 24/7, 365. That was of course a trick question, because all runways are used for landing and for taking off. Their function is chosen based on a number of criteria, and it changes throughout the day. That's because the wind speed and other parameters are measured, and the takeoffs and landings are planned based on those changes that happen throughout the day. Most of the time, they simply adapt to nature and to humans. You absolutely want to land the plane with the wind blowing to your face, and you want to take off when the wind is to your back. And if the residents that live around the airport are complaining about too much noise, yes, cargo planes will not take off or land during the night. The same can be said about data and analytics platform that is managed with Terraform. You absolutely have to know your stakeholders, and you have to tailor the platform for them. If you treat everything as infrastructure and apply DevOps principles to it, you can absolutely make a great data and analytics platform. If you plan, if you measure, and if you adapt your plans. And if you ask yourself every day, am I building the right thing wrong, or am I building the wrong thing right? With this, I would like to thank you for your time, and please connect with me on LinkedIn. Have a good day.